Talking about how to qualitatively assess solutions so we can predict the contents of an unknown solution, and our success criteria is being able to do that using precipitation out of a solution. So we talked about this back in the solutions chapter, but we can use our solubility table to try and analyze how or what chemicals are contained by a given unknown solution. So the way we do that is we add a known solution and then observe if precipitate forms or not. And since our solubility chart differentiates the different ions that will form precipitates with each other, we can use that to try and narrow down what chemical is contained within the unknown solution. Now, when we do that, what we will usually do is we'll ensure that our known solution only contains one type of reactive ion. So we'll often pair the ion that we are discussing or that we are using as a test with another ion that is non-reactive, like nitrate, ammonium, or sodium, because those compounds, if you look at your solubility chart, don't form any precipitates with any types of ions. So that ensures that we don't have two manipulated variables in our experiment. We're only manipulating one of the ions, and the other one is a spectator. It's not involved in the reaction at all. The other important thing about precipitation tests is that often when we do these, we will just take a sample of the unknown solution. We won't do this to the entire thing because we don't want the chemicals that we're adding in to contaminate and ruin our experiment. And sometimes also, if it's an unknown chemical, there might be an unanticipated reaction that we have to be careful of. So by doing it with just a small sample, it makes the experiment more rigorous, but it also makes it safer.